So Michelle will also be helping me with some slides. So as you can see here, we're trying to leverage lower Earth orbiting satellite stereo winds algorithm to investigate wildfire, aerosol plume, convection, and dynamics. And so we use lower Earth orbiting, geostationary, and the different pairings between the two. And here we have pictures of the team. We have the two lead senior scientists, Dong Wu, Jim Carr, myself, Tyler Summers, uh, Michelle, who will be presenting today, um, some slides, um, Dilan, Abhinav, Madhav, and Dylan. And they all help with algorithm optimization, aerosol differentiation, and investigating multi-layer translucent clouds using our method, which we'll get into in a second. Right, so I received a new investigator program grant from NASA, and these are the motivation behind that grant and the science questions. But you'll see that we can address a lot more science questions and a lot more collaborations than just this. Um, so we want to look at the impact of plume injection height on air quality and risk assessment predictions of wildfires. And we're using this what we call the stereo winds algorithm, or also referred to as the 3D winds, to detect the wildfire plume height and wind speed. We can detect U and V components as well. And we can also see the planetary boundary layer of the clouds around. And this algorithm, I'd like to point out, is a geometric-based algorithm. So it's not an atmospheric-based algorithm. So therefore, if we're looking at a combination of satellite images and there's features that are moving, then that's what we can track. And we can use several different wavelengths for that, depending on the satellite pairings that we're using. So again, the algorithm that we're using provides plume top height, wind velocity, and wind direction. And especially the top height, that's something different that GOES, for example, cannot provide. And some of the questions that we're trying to address are, what's the vertical distribution of the properties of wildfire plumes in deep convection? Um, what are the vertical transport and aerosol of these aerosol plumes, as well as the complex and localized wildfire meteorology that the models aren't capturing, but that we can see with those satellites. And so maybe that we can inform modelers with these data sets and this analysis. So just a quick recap of the stereo winds algorithm pairings. We're able to pair Geo with Leo, and here we have the different pairings. For example, Ghost 16 and 17 from NOAA with Miser, Modus, or Veers. And that's both Aqua and Terra Modus and JPSS Veers, as well as the Geo satellites. Oh, got a little bit cut off here, but we can pair the GOES with each other with Himawari, Meteosat second generation, and soon third generation as soon as it goes up. So we'll have an image later on where you can see how we're able to expand the coverage globally. Of course, the LEO GEO has some of the highest spatial resolution, but lower temporal resolution as compared to GEO pairings. And now we're getting into the Leo pairings. And here we pair Modus, Aqua, and Terra with Veers, as well as Sentinel 3A and B. And that's already been included into the algorithm. And here we have the different literature for each of the types of pairings. And you'll see the Leo is the latest, and it's in progress right now. So again, just to give you an idea of the coverage of the GEO pairing. So anytime we have overlapping regions between any of these two full disk geosatellite views, we're able to use two of those satellites to retrieve top height of a plume for wildfires. And it can also be applied to volcanoes, hurricanes, and other phenomena. But I'm focusing on wildfires. And then the gray stripes here represent Modus, but they can also be viewed as Sentinel and Veers. So you can imagine the kind of coverage that we'll be able to get over the poles. And again, why now? A lot of the instruments that are going up now have the capability that, especially the ABI instrument, the Advanced Baseline Imager, where it allows us to geolocate and parallax correct these retrievals, and we weren't able to do that before. So it's this new technology, which many of these satellites are using now, that allow us to do this. All right, so here's an example of the LEO stereo winds over the poles. So here on the right, we have a world view example, and you can see all the tracks here for Aqua, Terra, and Veers. And you can see that anytime we have 3 squares overlapping, then that's an area where we can have retrievals. And because we're having a lot of overlapping regions over the poles, we'll be able to have retrievals multiple times a day, not just once or twice or 4 times a day, much more than that, and especially if we add Sentinel. And so this is what the picture looks like for the Terra, Aqua, Modus, and then the Veers. So we have the blue and aqua are the Modus, and the pink reddish one is the Veers. And here on the left, we have another scene, and that's using Sentinel-A, the nadir and oblique views, along with Terra. And so you can imagine all the different combinations with all these Leos. So there's a lot to explore in terms of the wildfires over the northern regions. So that's something that we'd like to learn more about and potentially collaborate with you on, if that's something that's of interest. Okay, so this is just an example of Leo, Geo, and Geo pairings. Again, we can do different bands. So we can do IR, which give us the diurnal and diel cycles, not just the diurnal from visible during the daylight. And this is what it looks like. You get the full disk with the tracks for Modus, and here we're just showing the cloud height, but we could also have vectors telling you the wind direction and speed. And then this is just an example of the different wavelengths: visible, shortwave, midwave, longwave IR for GOES 1617, where they overlap. And you could see different features. Of course, for wildfires, we'd want to most likely focus on blue band, red band, and band 7 and 14. So here are some of the GOES accuracy, and this is also something that I'm investigating in terms, so this is in general, and I'm investigating in terms of wildfires. The GOES accuracy for height is within 300 meters, and wind is 0.5 meters per second. Same goes with Leo, and then the height is 200 meters. And that's something that, as we run more and more wildfire cases, we can look at the sensitivity of our algorithm for this type. This is an example in the Carr et al. 2019 paper where they did Modus GOES over the campfire in California. So here's the area that we're focusing on, and here's the product of the Modus GOES retrieval. And you can see the campfire here. These lines, the length of the lines here indicate the speed in reference to this line here, that's 10 meters per second. And you can see the cloud height increases as the colors get hotter. So the campfire plume here is pretty high, and also over the San Francisco area where they had the plume hover over 2 days, and they had the worst 2-day air quality for that year. And then I also want you to note that we have retrievals of clouds over the ocean, as well as sometimes we get more retrievals around the features, and that can help us provide information about planetary boundary layer. So in this case, the black is the terrain, which also is a sanity check for us. But if we had clouds, low clouds, then we could also help with the planetary boundary layer. And here's this transect right here is shown below, and you can see the plume that we're able to capture over the San Francisco area. And then again, the sanity check that we're retrieving terrain when there are no features in that scene. So just for a cumulus Pyro-CB case, the diurnal strengths of Geo. Here we have the California Creek Fire in 2020, And you could see the plumes here captured by GOES 17. We could see the North Complex fire, and then the Pyro CB, which shot over from the Creek fire, shot over the North Complex fire. So like 3 layers of clouds you could see from the shadows. And we were able to capture the height of this Pyro CB from using band 14. And so we could see the diurnal pattern. This would be for full disk with CONUS. So every 10 minutes or so, we're able to have retrievals. And of course, we haven't dived into this, but we also retrieve divergence and curl, and again, the UV wind components. And that's what we're going to investigate further as we expand our data set. So stereo wind's impact on injection height and time. And this is one of the reasons I was asking you about modeling. And this is a way our information could be beneficial to modelers. Here on the left, we have the GOES 16 true image during the Camp Fire and Woolsey fires. And you'll notice it starts at 16 UTC and it goes a couple hours later. Here in the model, you see nothing of a plume here, but we could start to see the aerosols already in the RGB image. The Woolsey fire is about to start, and as we progress, you can see the plume already starts to disperse in the GOES RGB image, but the model hasn't captured that yet. And then as we move along, you could see here the plume shape is very different, and the CMAC doesn't quite capture the plume. And so what our data set can help with is we can help with making sure that the injection height of the top of the plume helps the model inject the emissions more accurately or constrain them, as well as the time. And also we can help with the spatial patterns, because these AOD from GOES can help constrain and disperse these plumes more accurately. And that has to do with other work that I published with air quality, integrating the spatial patterns from satellites that do total column work. Okay. Michelle? So this is Michelle's portion, and I'm going to let her take over and introduce that.
Thank you, Mariel. Hello, everyone. I'm Michelle, and I've been working on a project regarding developing data quality flags that will distinguish wildfire plumes from other types of aerosols or clouds. And so I will be investigating pre-existing data flags used by GOES and MODIS. And based on the results that these flags give me, we will reevaluate and see if we need to proceed with learned methods to develop good data quality flags. So just for some background, like I said, I'll be working with GOES and MODIS, and specifically with GOES, I'll be working with the Advanced Baseline Imager, as well as the Aerosol Detection Program. So the ADP is based on separating smoke and dust observations from the cloud and clear skies over water and land. So this is obviously important in developing these flags and pinpointing exactly what is smoke and dust, and then relating it to the fires. So with MODIS, on the other hand, the tool I'll be focusing on is the multi-angle implementation of atmospheric correction, which basically just improves the accuracy of MODIS observations. So as Mariel mentioned previously, the 3D wind algorithm demonstrates that using both GOES and MODIS observations simultaneously returns much higher quality images than the satellites alone. So my project will be focused on developing data quality flags for these combination algorithms. So this is just a screenshot of the statistical analyses that we'll be running on observations. This one specifically is a creek wildfire observation, and this framework will serve as a basis for the analyses we want to do on the ABI-ADP product as well as the Modis-MAIC product. So we will be running very similar tests on those observations. And based on the results that this returns, we'll proceed with machine learning methods or otherwise, if that's necessary.
Thanks, Michelle. And I forgot to mention, Michelle is at the University of Maryland. She's an undergraduate studying math and computer science, if you can believe it or not. Yeah, pretty amazing. Amazing to have such bright collaborators working with me. So again, why stereo wins? We can get, again, higher temporal coverage and spatial coverage and have to UV wind components and direction, but also get that top of the plume height, which isn't available through GOES. So again, great tracks are the representative of the LEOs. So we have a lot of areas to work with and a lot of wildfires to explore.